Hello everyone. Different types of kernels are used by different operating system. Like Windows is using different type of kernel, Linux is using different type of kernel. So let us understand what are the different types of kernel. Okay. So if we talk about, there are three types of kernels especially. So different operating system have their own kernel, each designed to work with specific architecture requirement of that operating system. The common types of kernels are monolithic kernel, which is basically used by Linux or Unix kernels. So all the OS services are combined into a single and large kernel. So if we talk about the monolithic, and if you are aware of monolithic application, so monolithic application is that type of application where everything is into a single binary. So it means if you need any change into any functionality, whether it is a small or big, you need to rebuild your application. So same case with the monolithic structure or monolithic kernel. Here we are having the user mode. So in the user mode, we are having shell commands which user basically gives. Okay, so user is asking ls command, user is asking for the pwd command or any command or any shell script or something related to program where it needs the compiler and interpreter. So all those commands are in the user mode, and these are called system calls. So that system call goes to the kernel, and kernel is a monolithic structure. So it means everything is monolithic, and your signal, terminal handling, file system management, disk management, CPU scheduling, page replacement, demand paging, virtual memory, and kernel is connecting to the hardware devices also for these system calls. So it connects to the terminal controllers, device controller, memory controllers, etc. So all this work, which is basically a work related to the kernel, is in a monolithic structure. So file system is defined or managed by the kernel. Anything which needs hardware attention goes to the kernel. So there is no wrapper on top of this kernel. The request from the user mode goes to the kernel, and kernel perform all these operation and send back the response into the user mode. So this is the monolithic approach, and Linux is using monolithic structure only for its kernel. Now, let's move to the second type of kernel, which is called microkernel. In microkernel, basically what happens, you can say there are some wrappers on top of the kernel. So what does it mean? So consider that this is my microkernel. As the name suggests, it is microkernel, means it is having very limited functionality to perform. The kernel is minimal, providing only basic services like process scheduling, inter-process communication. Additional services are implemented as a separate user space process. Example of that is Minix, which is a educational version of the Unix. Okay. And some real-time operating systems. So that is basically the microkernel. Here you can see client programs, which is commands or shell script. So they are having certain wrappers. Here we are having virtual memory related stuff, file server related stuff. So those are not directly hitting to the kernel. So once the request goes to the virtual memory, so this kernel provides the services which are related to the virtual memory. Most of the things are happened on the user mode, not on the kernel mode. So this is the microkernel. Now, third type is hybrid. So what is hybrid means? Hybrid means combination of microkernel and monolithic kernel. So it's a combination of monolithic and microkernel concepts, providing a balance between performance and modularity. Windows, Mac operating system examples of OS with hybrid kernel. Kernel is essential to functioning an operating system. Its design significantly impacts operating system performance, security, and capability. So I hope you understand these types of kernel, and we will touch the kernel, or we will fine tune the kernel later when we come to the advanced level of patching in Red Hat Enterprise Linux. So basic or conceptual knowledge is required for this Linux kernel. Okay, so that's it for this lecture, and we will connect on the next lecture. Till then, bye bye.